In this video, I'm going to go over the first project for the MACT 180 class. On my screen, you can see that I have Canvas opened up, and you can see the icon that leads us to the 180 class. So if I click on the 180 class, it opens up. And on the home page, you're going to find quite a few things that you're going to be using this semester. Most of all, I've got the MACT 180 project list. The first project that we will be working on is the construction plane project. I open it up. You'll see images that we'll use to build or model up the part. And then we'll ultimately create toolpaths to engrave these labels that you see on each surface of the part. I also have a new session of Mastercam opened up on my screen. This is a brand new install. This is 2023. So if I minimize my screen, you can see I have the 2023 logo or icon on my screen. I'm looking at the default settings from a brand new installation. There are a few things that I will change before we move forward. I'm going to go to File, Configuration. And the first thing that I'm going to change is going to be the chaining. And I'm going to set plane mask in chaining. And then I'm going to set, I'll leave everything the way it is at this time. Go to colors, background gradient start. I'm going to set this to black, color 0. And then I'm going to set the background gradient end to color 0. If I scroll down, I'm looking for plane. The default color is blue, color 1. That's a little bit difficult with the color 0 background. I'm going to set this to color 15, white. And then I'm going to scroll all the way down, and where it says wireframe color, it's been relocated. I was going to set the wireframe color to green. I'll have to research this and see if I can find it. I got WCS. They might have relocated that color control in a different area. So for now, I'm just going to change those 3 items. And then I'm going to go down to toolpaths, and I'm going to uncheck lock feed rates. So those are a few of the things that I'm going to change right away. I will go back in and make a few other changes later on. So from here, I'll select OK. It's asking me if I want to update the system configuration file. I'll answer yes. Takes a moment to save. To see what the WCS looks like, I'll hit Alt F9. Or I can go to View, and where it says Show Nomens, I can control what I see here. And I'm just going to leave the T-plane or the C-plane. And actually, in this case, I'll leave the C-plane visible and make everything else invisible. I also have a plane that's visible on my coordinate system. To make that invisible, right-click, and then from the flyout menu, go to Plane Nome Settings, or Plane Nomen Settings. And where it says plane display, uncheck show plane. These are my personal preferences. If you want to keep that visible, you're more than welcome to. From here, I'll select OK. Once again, I'll save the configuration file. I look at it from an isometric view. This is my construction plane nomen. Alt F9 will make it visible or invisible. You can also control it with this icon right here under the View tab. I'll keep it visible for the time being. From here, I'm going to go back to the project page, and I'm going to study what's going on with these images. I'm going to reference these images to model up the part. If I scroll down, I've got some instructions, modeling the construction plane project. Using the images above, generate a three-dimensional surface model using the Mastercam software. Step 1, create a 3D representation of the part using wireframe geometry. There are several ways we can go about doing this. The way that I'm going to show you is probably one of the quicker and easier ways that I've come across. Not the only way to get it done, it's just the way that I prefer to do it. My wireframe geometry is green. And if I look at the images provided, I can see that the bottom portion measures 6 inches by 6 inches, 6 inches tall. And then the top part, the part with the angle on it or the drafted surfaces, the top part measures 4 inches by 4 inches, and the overall height is going to be 8 inches. So that's enough information that I need to move forward. From here, I'll go to Mastercam. I'll go to the Home tab, and I'm going to set my wireframe color to green just to match what I'm seeing on this screen here. So Home tab, wireframe color, I'll set it to green. And anytime I create a model inside of Mastercam, I like to free up the graphics area. I like to make it as large as possible. So for the time being, I'm going to minimize any managers that I might have visible. I'll go to View. And if something is shaded blue that is selected, that means it's active. I'm going to deselect all managers, and that closes all of them out. If I ever need to revisit them, I can just go back to the View tab and select toolpaths, levels. But for the time being, I'm going to make those invisible. Back to the project page, I'm going to start by creating a rectangular shape that measures 6 inches by 6 inches. And I'm going to center that on the origin. Go to the wireframe tab. In the shape section, under rectangle, expand it, you'll find rectangular shapes. I prefer this tool over the rectangle tool. So select rectangular shapes. When the parameters for this tool become available, I'm going to start by setting the origin to center. And then I'm going to set the width to 6. I'll hit the tab key. Then I'll set the height to 6. As soon as I hit enter and move my cursor into the graphics area, I'm seeing a preview of that 6 by 6 rectangular shape. If I roll my scroll wheel, I'm zooming out. I'm going to center this rectangular shape on the origin. I position my cursor close to the origin. You see it lock in the position. Once I see it lock in the position, left click. I've now created the base for this part. I'll select OK to exit the tool. I go back to the drawing. I'm going to use the translate tool to create a cube that measures 6 inches tall. To do that, go to Transform, Translate. Mastercam is prompting me to select entities to translate, something I'm going to change here. I'm going to right-click on this prompt, and where it says background color, I'm going to change that to red, select OK. And then I'll right-click on it again and make sure it's set to a large font. This way it's easier for me to see when Mastercam is prompting me to do something. So from here, I'm going to select the 4 lines. If I hold the Shift key down and then left-click on one of the lines that represents this square, all connected entities become selected. Once they're selected, I'll select End Selection. In the Delta Z, highlight it, type in 6, and hit Enter. The default setting is Copy. If I set it to Join, it connects the copied entity to the original entity with vertical lines, creating a wireframe cube. Everything appears to be correct. From here, I'll select OK to exit the tool. Because we use the Transform Translate tool, Mastercam was assigned temporary colors to the original item and to the copied items. To clear those colors, I'll right click, clear colors, right click, look at it from an isometric view. My C plane is at the top. It's a little difficult to see, but you can see that the origin, or Z0, is at the bottom of the part. And I need to know that when I create this 4x4 square at the top of the part. This 4x4 square is 8 inches above Z0. And I'm seeing that in this view. I have this dimension defining that. I'm going to set my construction plane to 2D. Then I'm going to set my Z value to 8, the overall height of the part. So if I left click in the Z value, a field becomes available. I'll type in 8 and hit enter. I'm going to create a rectangular shape 8 inches above the current construction plane. I'll go to wireframe. Back to the rectangular shapes tool. So under rectangle, you'll find rectangular shapes. This time, I'll set the width to 4 inches and the height to 4 inches. I position my cursor in the graphics area. You see a preview of that rectangular shape attached to my cursor. But watch what happens when I lock onto the origin. I let my cursor lock onto the origin. I left click, and it places that rectangular shape at Z0 centered on the origin. That's what I want. From here, I'll select OK. I'll need to draw in 4 lines. I'll need to connect this endpoint to this endpoint, and then I'll do that 3 more times, working my way around the top of the part. Go to wireframe, line endpoints. I have freeform selected. These are my default settings. I'll zoom in. I'm rolling my scroll wheel to zoom in. I'll let my cursor lock on to this endpoint. Oh, I'm still set to a 2D construction plane, so I'll go back and change over to a 3D construction plane. And while I'm here, I'll click on the Z value and type in 0 and hit enter. I'll hit escape to exit the line tool. Now it's asking me to specify the first endpoint again. So I need to change over to a 3D construction plane, 0, or Z being set to 0. From here, I'll let my cursor lock onto this endpoint. I'll let my cursor lock onto this endpoint. And then I'll repeat that process 3 more times. Lock onto this endpoint, lock onto this endpoint, and this endpoint, and then this endpoint, and this endpoint. Once you place those 4 lines, you can select OK to exit the line tool. I'll right-click on my screen, and I'll look at it from an isometric view. I'll right-click again, and then I'll select Fit. This would be a good time for me to save my work. You can currently see that it's wanting to be saved to this location. If I go to File, Save, I'm going to navigate to my working folder. And then inside of this folder, I'll create a couple of class folders. Right-click, New Folder. I'll call this MACT 180. And then inside that folder, I'll create another folder called Construction Plane Project. And I didn't save it in the correct location. So once again, I'll go File. This time I'll go File, Save As. I didn't create the construction plane folder. So once again, right-click, New Folder. I'll call this Construction Plane Project. And then inside of that folder, I'll call it Construction Plane Project again. And now if I look at the top of my screen, you can see the path to where this file is located. Now that we've created the wireframe representation of the part, I'll go back to the project page and I'm going to scroll down to the instructions. Step 1, create the 3D representation of the part using wireframe geometry. We just completed that. We're now moving on to step 2, create the levels shown above and place all entities on the correct levels. So for this particular project, we've got 4 levels. I'm going to create several more than what you're currently seeing on my screen, but this will be a starting point for us. I'm going to create a level called wireframe. I'm going to create a level called flat boundary surfaces. I'll create a level called drafting. And then I'm going to have levels 10 through, I believe, 18. And I'm going to identify each of the labels that you see on this part, and I'm going to place them on their own level. That way it helps me see things or allows me to make things visible or invisible when I'm trying to visualize what's going on with the part. So we're going to deviate slightly from what you're seeing here, but we're going to start by creating some basic levels. If I go back to Mastercam, I'll need to bring up my level manager. If I go to View, Managers, Levels, I've got one level with 20 entities on it. Let's name this level Wireframe. So you can double click in the name field and type in Wireframe. We need to create additional levels. We need to create a level for our dimensions, and we need to create a level for our flat boundary surfaces. To create a new level, select the green plus sign. You'll see a second level appear. Double click in the name field, and we can call this one Dimensions. Dimensions or drafting, either one will work. Another way that we can create another level, instead of selecting the green plus sign, in the number field, highlight it, type in 3, hit enter. And then you can enter the name value here or here. This time I'll enter the name value here. We'll call this one Flat Boundary Surfaces. And then I'm going to create some additional levels for the labels that we see on the part. I've got front side or front, our side, back, left side, and then I have these angled surfaces numbered 1, 2, 3, and 4. And then I have a top and I have a bottom. So let's start by creating a level for the front. Once again, I'll go back to Mastercam. To create a new level, in the number field, I'll just type in 10. And in the name, I'll call it front plane. I'll create an additional level, I'll create a level 11. This one I'll call our side, right side. Our side. I'll create a level 12. We'll name this one back plane. We'll create level 13. Enter. We'll call this one L side or left side. I'm going to name these angled faces 1, 2, and 3. Create level 14. I'll call it 1 or plane 1, whichever one works for you. I'll create level 15. I'll call it 2. Level 16. We'll call it 3. Like that. 3. Oh, that's the number. So this is level 16, and we'll name it 3. And I'll make that a capital T. Level 17, we'll call it 4. Level 18, I'll call it top plane or top. And then level 19, I'll call it bottom. Now that I've created the levels, let's create the dimensions or the drafting that we use to verify that our model or that our wireframe is correct. So using the drafting tools to dimension the part, we'll create these dimensions. I've got 1, 2, 3, 4, 5, and 6. Back inside of Mastercam, make the dimensions level the active level. Anything we create goes on the active level. Go to the Home tab, and then set the wireframe color to red. That way it's easy for us to differentiate between wireframe geometry and the dimension leader line and extension lines. If I look at the project page, I can reference these dimensions. They don't need to be exactly like you see on the images provided, but I'm going to use these as a reference and I'm going to get them pretty close. So wireframe or wireframe color set to red. The dimensions level is active. Go to drafting. I'm going to use the smart dimension tool. If I select this line, I'm not locking onto the midpoint. I'm not locking onto the endpoint. I position my cursor close to it. You see it become highlighted. I left click, and then I can pull the dimension off of the part. Now, before I even place it, I can see that the text is a little small. So while it's still active, inside the parameters for the drafting tool or the dimension tool, I can set the height to a larger size. So I just hit the up arrow. It increases the size in 100,000 or 0.1 increments, or just highlight it, type in 0.5. Once I get the dimension where I want it to be, I left click to place it. I'll also create this dimension, this 6-inch dimension. I'll select this line, not locking onto the midpoint. I just get close to the line, I left click, I pull the dimension off of the part. Once I get it where I want it to be, I left click to place it. At the top, I've got a 4-inch and a 4-inch. I select this line, pull the dimension off to the left, 4 inches. And if I select this line, pull it off of the part again, 4 inches. I now need to create some vertical dimensions. These ones are a little tricky. I've got a 6-inch dimension here, then I've got an 8-inch dimension here. I'm going to set my construction plane to front. Down on the bottom of my screen, you see where it says C-plane top, left click on it, and then set the construction plane to front. If I select this line, left click, actually jump back to top plane, set it to front. Or can I calculate dimension? My C-plane is set to front. T-plane is also front. I've got my follow rules on. If I go to view, planes, where it says follow rules, expand that and uncheck C-plane follows G-view and T-plane follows C-plane. Now, back in the drafting tool, Smart Dimension, I select this line and it allows me to create that dimension. I'm also going to change over to a 2D construction plane. I'm going to select this line and this midpoint and pull a dimension off of the part. Set my Z to 0. That centers us on the part. So now that I've placed the dimensions, I can hit escape to exit the drafting tool. And I'm using these dimensions just to verify that the wireframe representation of the part is correct. You can see that the dimensions here match what's on the images given to us on the project page. Once I verify that the wireframe is correct, I'm going to make the flat boundary surfaces the active level, and I'll make the dimensions level invisible. I can look at the part from an isometric view. So right click, isometric, right click, fit. And this would be a good time for me to save my work. File, save. Now that we've dimensioned the part, I'll go back to the project page and I'll scroll down to the instructions. We just completed step 3. We're moving on to step 4, create the flat boundary tool, or create the flat boundary tool to create the surfaces as shown in the images above. That's reading incorrectly. It should say use the flat boundary tool to create the surfaces as shown in the images above. So the flat boundary tool is a surface tool. So you're going to go to the surfaces tab. And in the create section, you'll see flat boundary. To use this tool to create the surfaces on all 10 faces, I'm going to change my C-plane to 3D. I'll select the flat boundary tool. And my mode is set to wireframe. 3D is active, and then the selection method is chain. I'm going to start by creating the face on the front of the part. I'll select this line. It comes to a branch point. I'm going to select this line or the red arrow, either one will work. It comes to the next branch point. I'll select this line or this arrow, and then I'll select this arrow. And that creates, or that selects the square on the front of the part. Once you have those 4 chains, or once you have those 4 lines selected, hit enter. You'll see a surface appear on the front of the part. To finalize the creation of that surface and stay within the tool, select the blue check. Okay, and create new operation. It brings up the wireframe chaining dialog box again. I'm going to work my way around the part, and I'm going to select the faces or the rectangular representations of those faces the same way. I'll select this line. I can select this arrow, or I can select this line. Once again, I'm just following the lines around that complete a square. Select that line. I'll select this line. Once I have all 4 lines selected, I'll select enter. I'm seeing a preview of that surface being created. I'll hit OK. And I can see that the normals are incorrect. And you can tell because one side is orange and the other side is green. And we can fix that here in a little bit. We'll use this tool right here. But I'm going to work my way through this, the surfaces, create all the surfaces, then I'll go back and I'll change the normal direction. So here, I'll select this line, this red arrow, and then this red arrow. Once I complete the chain, I'll hit enter. I'll hit OK and create new operation. On this side of the part, I'll select this line, this arrow, and this arrow. Once I complete the chain, I'll select OK. And then I'll select OK, create new operation. And for the time being, I'm going to select OK and exit the tool. And actually, for what we're doing, the surfaces are okay. Everything is orange. It's not showing which side is the outward side and which side is the inboard side. So we'll keep moving forward with the flat boundary tool. And now we're going to create these surfaces right here, these angled surfaces. We're going to create them in the same method that we created these vertical faces. I'll go back to the flat boundary tool. I'll select this line, this line, this line, and this line. Once the chain is complete, I'll hit enter or the green check. You can see a preview of that surface being created. I'll select OK, create new operation. I'm also getting a prompt. Click a surface to flip its normal. So now that if I scroll over, you see the arrow pointing outward. So the normal is facing outboard. And we'll talk about that more in a little bit. I'll select OK, create new operation. And I'm going to continue making these 3 additional angled faces using the same method. I'll select this line, this line, this line, and this line. Once I have the chain complete, I'll select OK. The light blue is facing out. If I scroll over the surface, you'll see the normal or the arrow pointing out of the surface. That's what I want. I'll select OK, create new operation. I'm tumbling my view. I'm now going to create this angled face. I'll select this line, this line, this line, and this line. I'll select OK. It says click a surface to flip its normal. If I scroll over it, you can see that the normal or the arrow is pointing inboard. If I left click on it, it changes the color of the surface and the arrow is now pointing outboard. I want the arrows pointing outboard. I'll select OK, create new operation. And now I'm going to select these lines to make up this surface. Select OK. I'll select the surface. You can now see the arrow pointing outboard. I'll select OK, create new operation. I need to create 2 more surfaces. I can select this line, this line, this line, and this line. Select OK. If I select the surface and then I scroll back over it, you can see that the arrow is pointing outboard. That's correct. I'll select OK, create new operation. And then I'll do the same thing on the bottom of the part. I'll select this line, this line, this line, and this line. Once you complete the chain, select OK. If I select the surface and then scroll back over it, you can see that the arrow is pointing outboard. That's correct. I'll select OK. And then I'll select the green check. Actually, I'll exit out of the chaining dialog box. And I've created all of my surfaces. Right click, isometric. If I tumble the view, you can see that the part is now closed. I don't have any open faces. Now, I did create some surfaces with their normals pointing inboard. To change that, I can go to the normals and I can select change. And right away, you can see that the ones that are facing or the ones that are this light green, those are the ones that have the normals facing inboard. So what I'll do is I'll select it, it flips it, select this one, it flips it. And as it flips the normals, you can see that the face changes to the color orange. Once I have all of the faces with their normals facing outboard, I can hit escape. I'll right click. I'll look at the part from an isometric view. I'll right click, I'll fit my screen. And this would be a good time for us to save our work.